All right, so let's look at this. Today we're going to talk about rates of change. So in algebra, when we talk about rates of change, we're really talking about the slope of a constant, what we call a constant rate of change. And what that means is that the rate of change doesn't change. It's constant. It remains constant. So I go 5 miles per hour. That means I'm constantly going at a rate of 5 miles per hour. I spend $5 per gallon of gas. So for every gallon of gas that I purchase, I'm going to have to pay $5. The board's up here. Okay. So let's look at this one. So this one says the rate of change is the ratio of the amount of change between the dependent variable. And let's talk about that. The dependent variable is usually y. So write that in next. Or the output versus the independent variable x. So then it says Eve keeps a record of the number of lawns she has mowed and the money she has earned. Tell whether the rates of change are constant or vary. So I'm going to assume. So let me back up before I assume. Does the amount of money she makes depend on the number of lawns she mowed, or does the number of lawns she mowed depend on how much money she makes? Yeah, the money she earns depends on how many lawns she mowed. So the dependent variable would be the amount of money she earns. Therefore, the independent variable would be x. Now, in a fancy math class, we'll say x or the independent variable is arbitrary, that you can pick. Arbitrary is a fancy word that means that you randomly pick. In this particular case, Eve can choose to mow 1 yard. Eve can choose to mow 5 yards. And the amount of money she makes depends on how many yards she mows. Yes, question? Well, it depends on the context. In this particular case, the thing that's arbitrary is the number of lawns we mow, right? Okay. That's a great way to look at it. Basically, what the student is saying is, well, if you want to make a certain dollar amount, you just got to figure out how many lawns to mow. There is a scenario where you could do that, but in this particular case, it's the other way around, right? So anyways, so it says identify the input and output variables. So what are the input variables? What are we measuring for the input? Number of lawns, right? So we're going to do the number of lawns. What's the output then? Dollars earned, right? Money earned. Skrilla. Chips. Dead presidents. All right, so now to find the rates of change, what we do is we're simply, and I'm going to write this out for you guys. I'm going to make it really complicated because this is what you're going to learn at Algebra 1. I don't expect you to understand the complicated part about this, but it's one of those things, if I do something complicated today, it'll be just a little bit less complicated tomorrow, and then I do it the next day and the next day and the next day. And so when you take Algebra 1, you'll be like, oh yeah, Mr. Adams taught us that. So to find the slope, M, this means, wait, let me change this to a different color. To find the slope or rate of change, so remember, write this down in your book somewhere, rate of change, just kind of jot this down, means slope. And slope has a formula. And you say, well, Mr. Adams, why do we use the letter M for slope? Because the mathematician that invented this portion of algebra, it's actually technically analytical geometry. He was French. And M stands for the root word that means to modify. So when we talk about how something changes over time, in French, it's more like the rate of modification. So that's why slope has the letter M. All right. His name is Rene Descartes. He was a famous philosopher and consequently a brilliant mathematician. So we're going to say, you ready for this one? This is the hard part. It's going to look confusing. Y sub 2 minus y sub 1. What? All over x sub 2 minus x sub 1. So let me tell you what I'm writing down. When I say x sub 1, it is pronounced x sub, and I'm going to use a fancy word. We say x sub 1. That's how you say it. But we're saying x subscript 1. And what that means is I'm focusing on the first x. Now, it doesn't matter which is first and which is second. Think of it like a license plate, right? If I have a car, here's my car. This is the back of the car. And I have a license plate that's 1. That's the back of my car. Here's the tire. Peeling rubber. Here's my tire. Peeling rubber. Looks like a house on wheels. Hey, perfectly drawn car. Anyways, if I say car number 1 or car number 2, if I look at the license plate on the car, I can tell which one is which. So that's what we're doing. We're going to compare x's and y's. And so really what I'm saying is take the second x comma y. And so there's points on the graph. We'll say x1 comma y1. And we'll say stuff like x2 comma y2. We don't want to get them confused. We want to match the y's with their corresponding x's and vice versa. So I said all that to point out that in this particular case, when they say 45, that comes from here, which is a y value. So this is like y2 minus 15, which is this one here, which is like the first y value. Also, we do the same thing with the x's. We're going to say x sub 2, right? Or x sub 2, which is this one here, x sub 2 minus x sub 1. That's where those numbers come from. So I'm going to take the second x, subtract the first x. I'm going to take the second y, subtract the first y. Does that kind of make sense? I'll slow down, let you look at it, and kind of see where we're getting the numbers from. Okay. Is there any questions about where we're getting the numbers from? How do you feel about what we're talking about so far? Thumbs up if you get it, thumbs down if you don't. Okay. If you're in the middle, that's okay. We just got to go over it a couple more times till it makes sense. All right. So what is 45 minus 15? Anybody know?
30.
30. So we're going to say that this is 30. And what's 3 minus 1 is 2. What's 30 divided by 2?
15.
It's 15. So what I discovered is that my rate of change is 15. In other words, she's getting $15 per lawn. That's what that means. Let's go and check. If I get 8 lawns and I charge $15 per lawn, let's see what that is. So if I go, you can do this on your calculators with me. If I have 8 lawns and I charge $15 each, 8 times 15 is $120. Let's see if that's what it says. Whoa, that's pretty good. Well, it's not bad for a kid with a lawnmower, right?
I charge 20.
You charge 20?
That's me.
Hey, you could. We'll talk after this video. Okay, Mr. Adams, I got a small yard. I need it mowed. All right. So now, wait. We got to back up. We want to go from day 2 to day 3. So we start with day 3. So in here, what do I put for my second y, or my y from day 3? 90 minus what? 45. And then we get 6 minus 3. What's 90 minus 45? 45. Calm down. And then what is 6 minus 3? 3. What's 45 divided by 3? 15. So because we say that it's a constant rate of change, if it is in fact a constant rate of change, they should all equal 15. Let's double check on the last ones. We're going to do day 4 to day 3. So, yeah, 20 minus 90. And then what do I put here? 8. So what's 120 minus 90? 30. What's 8 minus 6? What's 30 divided by 2? So she's charging $15 a lawn. Think this is a game? You think I'm playing around?
Yes, sir.
Just maybe, possibly.